Hey class, it's Professor Rourke again. Okay, now we're looking at number 12 from the skills assessment. So if you remember number 12, it said to find and simplify the difference quotient. And then they give you the difference quotient. It says f of x plus h minus f of x all divided by h for the following function. Hint, rationalize the numerator. Wait, what? So right now, it probably makes no sense why they would ask you to do this. I promise you at the end of chapter 2, you'll be like, okay, I see what they were doing there. But right now, it doesn't make any sense. Okay, no sense at all. I don't, it's just like, why are you doing this to me? Technically, what we're doing, they sometimes would refer to this as like finding essentially h is going to equal like the difference. Let me keep it like pretty straightforward. Difference between like x1 and x2. Okay, so how they introduce this difference quotient is it's like a different way that we can find like the average rate of change between two functions at a certain point. Okay, and if you've gotten to 2.1 yet, you might be like, okay, that sounds kind of familiar because in 2.1, they start talking about how we're trying to take the slope between 2 points and bring them closer and closer and closer together so that we could maybe try to get a good estimate for the slope at 1 point. Okay, the instantaneous rate of change, like what's actually happening at a specific second in time versus like, oh, okay, I traveled an average speed of 20 miles per hour from 1 to 2 minutes, or I traveled exactly 21 and a half meters per second at 1.5 minutes, right? So we're talking about trying to just go from, again, the average to the instantaneous, and this is how we're going to do it, but it's tricky. It's tough at first. Okay, so first things first, my function's f of x equals 6 times the square root of x. Yours number could be different, but it's the same idea that you have to have this radical in here. Okay, so first up, what I would recommend you do if you're not feeling comfortable is just to go off to the side, depending on what the function is. It's just like, okay, hold on a second. What is f of x plus h? Okay, so depending on what the function, like the original function is, it could look a variety of different ways. If then essentially, like if x was squared, then you would need to like square the quantity x plus h. So you'd say x plus h times x plus h and FOIL it out. If it was x cubed, you'd have to like, expand out x plus h times x plus h times x plus h. Maybe you got to distribute a number. There's all kinds of different ways this could look. For radicals, actually, this part's not bad because we just literally take out an x and put in x plus h. So it's like, okay, that's it. But again, depending on what the function is, sometimes that could be a bit more lengthy than others. Okie dokie. So I'm going to go ahead and I'm plugging it into the difference quotient. So we have 6 times the radical of x plus h minus f of x, which is just 6 times the square root of x. And then this is all divided by h. Okay, so essentially this is it. We're done. We did the difference quotient. Ta-da, that's it, okay? However, they often will not want you to leave it like this. And this is, again, one of those that doesn't really make any sense right now because it's just like, why not? That seems fine to me. But eventually, once we start plugging in the limit as h goes to 0, you'll see that the trick is we always are doing some sort of algebra manipulation, some algebra magic to try to get the h canceled out. That's the name of the game, because we want to get the h canceled out so that you can actually plug in 0 for h. But again, right now, makes no sense. So they try to give you, that's why they try to give you like this, like, I don't know, not great hint. It's rationalize the numerator. So that's something else that we typically don't see. You might remember what rationalizing the denominator looks like. We do that sometimes in algebra and pre-calculus and things like that. But we don't often ask, or we're not often asked to rationalize the numerator. But that is essentially what we're going to do. So you do have to remember how you actually rationalize a numerator or a denominator or anything. Since there's 2 terms in the numerator, we need to multiply by the conjugate. Okay, so instead of 6 times the square root of x plus h minus 6 square root of x, it's just plus, okay, in the middle there, plus the 6 square root of it. Plus 6 square root of x. Whew, okay, so what this means from here though, okay, and I know it seems bad, but I promise you, it's not that bad in a second. We multiply that on the top and the bottom. And what do we do from here? The bottom, the key is the bottom we leave. We're not going to mess with the bottom. Okay, the bottom's going to stay for right now. H times 6 times the square root of x plus h plus 6 times the square root of x. We're We're going to leave that hanging out there. Okay. And then at the top, the whole reason we had to do this was so that we could FOIL this out, so that the radical is gone in the numerator. That's the idea. Which again, I know, unless you really kind of foresee why we're doing this, it doesn't make much sense. You're like, okay, I guess I can. So conjugates, remember the whole idea of if you multiply a conjugate, so like a plus b times a minus b is a squared minus b squared. We could FOIL this out, like we could do the f, the o, the outer, and the I, the inner, and the last. But we don't have to, because the whole idea is it's a conjugate. So if we multiplied the outer, you'd get like negative AB, and the inner would be positive AB, negative AB, positive AB. They're going to be eliminated. Okay, so now no matter how ugly we might be talking about for conjugates, the same thing's going to apply. So long story short, we don't have to FOIL. It might feel like we're breaking some rules, but we're not, I promise you. So we want to multiply 6 times 6, can do that, and then multiply the square root of x plus h times the square root of x plus h, which hopefully you'll be like, oh, okay, that's just x plus h, okay? And then we're gonna do the same thing. Again, we could do the outer and the inner, but I promise you they're just gonna eliminate each other. And so now we can just multiply the last terms, which would be negative 6 times 6, which is 36, and then square root of x times the square root of x is x. Okay, so we go from this terrible looking thing to be like, that's not that bad. Okay, because we have 36x plus 36h minus 36x. And it's all divided by can of worms on the bottom. We're not going to mess with the can of worms on the bottom. We're just going to leave that hanging out there right now. Okay. And again, I know it's tricky for now to know why we even want to do this. So the reason we did that, we got rid of the radical, and now I'm like, oh, okay. On the numerator, I have 36x, and I also have another like minus 36x. So I could just go ahead and like eliminate 36 minus 36, and be left with 36h on the numerator. So do be careful. I still have people all the time trying to like cancel some stuff out early. Like you cannot just be canceling out the h without having gotten this down to one term. Okay, it's the whole idea of like canceling a factor versus a term. I know it's challenging, but we had to get rid of the x's so that we just have 36 times h, and now we can go ahead and cancel out our h's. And so long story short, at the end of the day, we are left with 36 divided by, there's some extra 6's in here. I could probably factor those out, but it does say simplify, so I guess they want me to do that. Okay, so I have 36 divided by 6 times the square root of x plus h plus 6 times the square root of x, and I guess I'll just go ahead and factor a 6 out as well, mine as well, while I'm here. Okay, while I'm doing this, because I can see that 36 and 6 would be nice to cancel out. Okay, so all of that loveliness comes down to 6 divided by, go ahead and make sure I write this correctly, the square root, I'm trying to remember, yeah. So you can just type in also SQRT for square root if it makes it easier. If you have like a lot of square roots or something, it's up to you, SQRT. So I'm the square root of x plus h plus a square root of x. Okay, so I hope that's helpful. Again, that's number 12 from the skills assessment. I'm just gonna try to make videos as quick as possible, but if you are still confused about anything, always let me know. Okay, thanks class.